I'll just go present the experience using Heart Vista for cardiac MRI at the Brigham. These are pilot experience on scanning volunteers. So, and I thank Heart Vista for inviting me to present this experience. Here's my disclosure. So just go right into it. I won't repeat many of the steps that are so nicely presented by Dr. Salerno and Dr. Hu. The process of scanning is very much the same using Heart Vista. Now, so we are somewhat lucky that our setup was actually our setup, hardware setup for installation of Heart Vista was actually pretty simple, because we have been using a external sort of I was told fairly high-end Linux machine to process all our images. So we already have a system like that available, and that actually makes things a lot easier, because we can just Heart Vista, the colleagues from Heart Vista just install their software on the Linux machine, and I was actually been running in this control the scanner, perform the scanning using the Heart Vista software on the machine, and it's been fairly smooth in terms of conducting all the images fairly quickly. It was just basically over a weekend they came and installed it, and they installed it online and then show up, and we started scanning volunteers. And the post-processing is pretty much the same, but indeed Heart Vista has built-in post-processing that probably would make things even faster. Of course, the plan is also just like what Dr. Salerno mentioned. We also plan to perform, scanning with Siemens homegrown Siemens product pulse sequences, so that our research protocol can be done smoothly. So this is our typical protocol at the Brigham, and this accounts for about 80% of all our scans. We do about 1,600 a year. So this is the typical platform for cardiomyopathy, which is fairly similar to many of your programs. The different T1 and T2 mapping, perfusion, rest. Sometimes we perform rest and stress as well, depending on indications, followed by cine function and LGE and post-contrast mapping sequences. There's some variation to it, but you can see that even a basic protocol like this will cost us about 50 minutes on average, depending somewhat on the skills of the technologists. But so we try to answer the question: Can we reproduce this? What do we gain from this? Now, because we are only testing volunteers, we did not have the IRB to give contrast, so we have to we actually skip the performance of post T1 mapping, but everything else is the same. So we try to replicate the same sequence, although we did not do post-contrast T1 mapping. So here's the typical image quality, and I would say, so we've scanned 9 volunteers, and I have images for 8, but I would say most of them, again, these are younger patients, younger people, and they are obviously asymptomatic and well patients. So image quality is consistently quite good. I don't remember a case out of this pilot experience that is not like this, that is not high quality like this. And Heart Vista generates the automated quantitation of the left ventricular and right ventricular function and sizes. And T1 mapping is typically, also of high diagnostic quality, and T2 and T1 mapping. And we quantify the T1 and T2 mapping. The values are fairly similar to what's in the report. Again, these are just volunteers. They're in the normal range and a small number. LGE, you can see that there is a fair amount of tissue differentiation of contrast, despite the lack of contrast injection, which we're glad to see. The image is overall, again, these are sort of single shot approach. So I think if there is any motion blurring, is not any more than our usual single shot LGE sequences. Heart Vista also have the other version, I believe, the segmented version as well. So in terms of, what is the quantitative assessment based on the limited number? We only, as I mentioned, we only scan 9 normal volunteers on a single weekend. So the diagnostic quality would look at these pictures, all the series lumped together and put them in a 5-point scale. 5 being excellent, as shown here. And again, there is really, I don't remember any case that has more than a little bit of mild motion blurring or mild artifact. Overall quality, again, this is not really a systematic comparison against patients, but overall the study image quality were really, really good. Given this is a limited protocol, despite this is a sort of a limited protocol, the scan time is impressive. This is the most important message that I can provide so far is the consistency. And to us, this is very important. We have 4 scanners across 2 different campus sites, and we have 8 trained cardiac technologists doing all sorts of different things, and they cannot always stay in one spot. And we have a large batch of other technologists sometimes have to fill in for this reason, and they're not cardiac trained. And you can see that why, right now we have to ship some patients from another campus by an ambulance to the Brigham main campus to get a cardiac MRI. So you can imagine that to overcome this sort of challenge, we need something that is automated is useful. This is just based on normal volunteer, but the consistency of scan time for this protocol that I've shown you it is actually what drives a lot of interest here. When I was scanned, one thing that was consistently observed was there's no interruption. When our real patients are scanned, our technologists are interrupted by phone calls, by our fellows talking to them, and I don't know, they sip the coffees and something bad happens on the scanner or something. All kinds of reasons that a scan can be interrupted. I actually spent a few mornings just observing how scans are done, and I find the amount of interruption on scanning is just horrendous. And I feel that this is actually one very attractive nature of this technology is that there is no interruption. And I can say that when I was scanned, I was actually feeling there is not rush. I feel fairly comfortable with the pace, and the scan time is in the order of about 20 minutes in this volunteer-based protocol. So that was our experience, and I think we're also aiming to look at how we can use XSI to perform scanning. And overall, there's a lot of interest, and mostly because of the consistency of it can potentially improve our wait time of 30 days down to less than a week. So this is the sort of the background interest in my location.